Function notation. So when an equation is used to represent a function, it's helpful to give it a name. For example, the equation y equals x squared plus 2 gives y as a function of x and can be expressed as f of x equal to x squared plus 2, where f is the name. This is called function notation. If you're familiar with programming, or for instance, not even programming, but maybe something like Excel, Microsoft Excel, a spreadsheet program, they use functions a lot. And for instance, if you're calculating an average in Excel, they have a function that we call average, and it takes an input, and what it returns is the average of the input. So the input is data, but the output is a single number and whatever the average is. Okay. Likewise, in math, our names aren't so descriptive usually. We usually use a letter like F or G or H. But the idea, like for instance, this function here that we have, f of x equals x squared plus 2, well, we think of that here as, well, we input some value and we get some output out. Well, whatever that input is, you take the square of that input and you add 2. And that gives you the output. Okay, so for instance, if we took 5, we would square the 5 and add 2. So we would get 25 plus 2, which is 7. Excuse me, 27. Okay, so it's helpful to think of it as like a placeholder. That x value is like a placeholder, and that's how we evaluate functions. So for instance, this next example here, we're asked to evaluate the function f of x equal to x minus 4 all over x plus 3. So once again, let's express this more generically. So we have f of an input, right? That's the input. And the output is going to be whatever that input is minus 4. And then you divide that by the input again, but this time plus 3. All right, so let's see how this works. So first example, we have f of 5. So we get 5 minus 4. And then we divide by 5 plus 3, which would give us 1 over 8. Part B here, we have f of an input of 4. So we get 4 minus 4 all over 4 plus 3, which gives us 0 over 7, or 0 divided by 7, which is 0. F of negative 3, so this time we have an input of negative 3. We have negative 3 minus 4 over 4 plus, back up there, negative 3 plus 3, to get negative 7 over 0. This is undefined. We can't divide by 0. So not all inputs make sense, and so domain is negative 3 would not be part of the domain of this function. D, which is f of x plus 4, we have an input of x plus 4, and then we're going to subtract 4 and divide by the input again, plus 3. So we're going to get x over x plus 7. All right, so that's how you evaluate a function. Let's see another example. Given f of x equal to the square root of 3x minus 2, find the following. Okay, so for a here, we're actually find the value of f, or our function, for an input of 9. So what do we get? Well, f of 9 is equal to the square root of 3 times 9 minus 2. So we're going to get the square root of 27 minus 2, which is the square root of 25, or simplifying that would give us just 5. So an input of 9 gives us an output of 5. B is a little bit different here, because we're asked to find the values, or x values, such that f of x equals 8. So notice this time we're not given an input, we are given an output, right? So remember, the x value here is the input, and we're given the output of 8. So we're kind of going backwards. And so if this is the case, what we're doing here is essentially solving the equation, whatever the input, whatever the function value is, and we know that it's the square root of 3x minus 2, which equals 8. And we would solve this equation by squaring both sides to get rid of the radical and then isolate x. Okay, so we get 3x minus 2 on the left, 8 squared on the right, which is 64. Now we solve by adding 2 on both sides to get 3x equals 66. And then we would divide both sides by 3. So that gives us x equals 22. So an input of 22, right, would give us 8. And you could double check that by plugging it into the equation or into the function to see that you get an output of 8. All right, C, we were given g of x equal to x, and then we're asked to find the x values such that f of x equals g of x. So once again, we want to know the input that we could plug into f and also into g, the same value, the same input, so that the outputs are the same. So we're looking for the inputs that you can plug into this function to get the same output. Alright, so in other words, we're solving an equation again. F of x we know is the square root of 3x minus 2, and we want to know when this is equal to g of x, which is the function x. Alright, so we, just like last time, we would square both sides to get rid of the square root. So we get, on the left, just the radicand, 3x minus 2. On the right, we get x squared. Well, this turns out to be a quadratic equation. So we could say add 2 on both sides, and we would get 3x equal to x squared plus 2. And I could also subtract 3x on both sides to get, on the left here, 0. And the right, we get x squared minus 3x plus 2. Okay, we could solve this by factoring. 2 numbers to multiply to give us 2 and add up to negative 3, or negative 2 and negative 1. So it factors as x minus 2 times x minus 3. Then using the zero factor property, we could set each one of those to 0. So we get x equals 2, or we get x equals 1. So the inputs that would give us the same output would be an x equal to 2. Plug x equal to 2 into f of x and g of x. You get the output of, what is the output? I'm not too sure. Won't plug in 2, so 3 times 2 is 6. 6 minus 2 is 4. And then take the square root of that is 2. Okay. So the output would be, and then the other output is x equal to, the next input that would give you the same output would be x equal to 1.